Hello everyone, we are team number 1, and for our final project we decided to implement house price prediction project, which uses deep learning. We created neural network model which will help us to identify if listed house price is above average or not. For this project we decided to use Google Colab, which is really helpful in when you need to implement deep learning models. So let's start by implementing Panda library, which will help us to read our input dataset. So, and here I am saving our CSV file into data variable, and let's display our data and see what it has inside. As we can see, it consists of 1460 rows and 11 columns. So first column is ID, so we can skip it. So it contains of 9 input features and 1 predicted value. So our model needs to be able to predict this above median price, which will tell us if house is overpriced or not. So 1 means true and 0 means false. Next step will be to convert our data into array, since neural network models only can work with arrays. So here let's display the dataset and see how it looks. As you can see, our data was transformed into array. Now we need to partition our data. We need to tell which columns are will be input features and which column needs to be predicted. So we are telling here input feature will be column from 0 to 9, and predicted value will be last column, column number 10. Here we're just importing some additional libraries. Next step will be to normalize our data. Since our model cannot accept any data type, first dataset needs to be clean, normalized. We need to remove all null values, and in order to do that, we will be using a min-max scalar method, which will transform our data into range from 0 to 1. So as we can see, let's run it and let's display and see how our data looks like now. As you can see, all values are between 0 and 1. Now let's import some additional libraries. So next step will be to divide our dataset into training dataset and test dataset. Since we weren't given, we don't have separate test datasets, we will just divide the main dataset into 2 parts. So test dataset can be used in order to evaluate our model, which means it will not be used in order to train it. So let's partition our data. Here we can display size of our arrays. Now we came to step where we need to create our neural network model. We will be using Keras models, and we decided to create sequential model. So let's import libraries. Okay, it's imported. So here's our model. We created sequential model which consists of 4 layers, 3 hidden layers and 1 output layer. All hidden layers are using activation function called ReLU. What it does is it just removes all negative values and sets them to 0. It's most used activation function currently. And for our output function, we are using sigmoid activation function, which which is values for sigmoid function are between 0 and 1, and it's mostly used if we want to know probability of the output. So and here also we're defining input shape, means we're defining what's input feature number, so we have 10 inputs. Okay, so let's create our model. By the way, those numbers here means that how many neurons we have, and the last one will be we will have only one output value. So now we have to optimize our model. So for optimization function, we're using stochastic gradient descent. What it does is just selects random value in order to find a gradient descent. That value, gradient descent value, is used to upgrade parameters of our model. So what it does is on each step of training it needs to adjust values. So in order to know the best value, we need to calculate gradient descent values, so our model will perform good. So the selected optimization function doesn't select a whole data set in order to calculate gradient descent. It will just randomly select some values. For loss function, we are using a binary cross entropy. What loss function is, it tells us how good our model is predicting. So loss function, better our model does, less loss value should be. So in binary cross entropy loss function, each calculation is done separately. So on each output vector, when on each output vector loss function is calculated, those results will not be affected by next calculation. So also we can tell our model what additional parameter we want to see. So we want to see accuracy of our model. So okay. Next step will be to actually train our model. In order to train our model, we're gonna call fit method, and we will pass our data sets. Also here we are defining batch size and epochs. Epochs is number, how many times you want the model to iterate through dataset. So let's go ahead and run it. It might take some time. Okay, it finished. As you can see, our loss function first was 0.63, and as we're increasing number of epochs, loss function is decreasing, which means it's good, and our accuracy is increasing. So let's evaluate our model and see how accurate the results are. As we can see, it's 86% accurate, which is a good value. So let's visualize our data. Okay, as we can see that how our loss function is decreasing, but so more number of epochs we have, lower is loss value. But it doesn't mean that if we have, like, by increasing number of epochs we can get better accuracy. So let's see how accurate our model is doing. So as we can see, we started from 50% and accuracy of our model is decreasing to 85%, and when it reached 30 epochs our accuracy was at 85%. That's all for today. Thank you very much.